Don't forget to subscribe and ring that bell.
Here we go. 2019 AP Calculus AB. Free response question Chingwe. Number 5. No calculator. Pfft, keep your calculator. I don't need it. You don't need it. We can't use it anyways. So let's just start the question. Number 5. Let R be the region enclosed by the graphs g of x equals -2 plus 3 cosine pi over 2 times x, and h of x, which is 6 minus 2 times x minus 1 squared. The y-axis and the vertical line x equals 2 is shown in the figure above. Find the area of R. I'm going to be honest with you here, kids. Normally, okay, first of all, question 5 has just 3 sections, A, B, and C. Normally, the most work is part C, or sometimes if there's a part D to a question, those are the bigger, more rigorous algebra sections. For 5, it happens to be A. As soon as we get past A, it's going to be smooth sailing. So let's just grip it and rip it, kids. It's a golf term. Let's do this. Okay, so first of all, I need to find area R. So I know that it is top curve, okay, minus the bottom curve when I integrate, okay? I'm doing area between the curves, so it's top curve minus the bottom. The thing is, how do I know what's the top and what's the bottom? Well, it looks like this red line is at 1. Okay, so it's at the coordinate when x is 0, y is 1. And this blue curve looks like when x is 0, your y is 4. So technically, you can plug a 0 into each equation, g of x and h of x, and see which one outputs a 1 and which one outputs a 4. Let's start that. Let's put a 0 into this. Okay, if I put a 0 in for this x, 0 times anything is 0. What's the cosine of 0? You should know that the cosine of 0 is 1. 3 times 1 is 3, and I have this -2. -2 plus 3 is 1. So when I plug in a 0 to g, the output is 1. So this is my red line. G of x is the red line. We've established that. I should use the bigger eraser. Don't know why I didn't, but here you go. Go back here. This is your g of x, which means this is going to be your h of x. All right. So when I integrate these, it's the top curve minus the bottom curve. All right. And we're doing it from 0 to 2. They tell me the line x equals 2. So I'm going to integrate from 0 to 2. The top curve, which is 6 minus 2 times x minus 1 squared. All right, this is the top curve, minus the bottom curve, which is -2 cosine of pi 2 times x. And this is all the same dummy variable dx. Now, I suppose there are different ways you can break this up into 2 integrals or whatever, but I'm just going to use that old mentality. When I'm taking the derivative or I'm taking the integral of something, I'm just going to go right down the line, right? So I got 6, I got this one right here, I got this right here, I got this one right here. Well, actually, that might be one whole one right there. I'm missing a plus. There's a plus between here. There you go. But before I do that, I'm just going to distribute this minus sign, shall we? So now I've got the integration from 0 to 2 of 6 minus 2x minus 1 squared plus 2 minus cosine pi over 2x dx. So now I'm just going to integrate this, integrate this, integrate this, integrate this. Okay? That's just the easiest thing for me to do. Maybe you do it a different way, and that's fine. Going to need a lot of room here. The integration of 6 is just 6x minus the integration of this is a constant too, so that's going to stay on the outside. When I integrate this here, okay, x is the same thing as saying x minus 1. If you want, you can do you can do u sub, but I'm going to add 1 to that exponent to make it 3, then divide by 3. So that's what I have. All right. The integration of this 2 is just 2x. All right. Here's where poop is going to get real. Minus. I am definitely going to try and do a u sub with this thing right here. So I'm going to do this off to the side. If u is pi over 2 times x, du is pi over 2 dx. But notice in this thing right here, I'm only going to have the dx. So I'm going to multiply this by 2 over pi. 2 over pi. So 2 over pi du, these go bye-bye, is going to go in for my dx. Okay? So I now have the cosine of u du, and the 2 over pi goes on the outside. What is the integration of cosine? Well, sir, it's just the sine. 2 over pi, and this would be the sine of u, but back in for u, I need to put pi over 2 times x. So this thing right here is what I'm getting for this integration. So we got minus 2 over pi times the sine of pi over 2x. Whoo! And don't forget, I want this from 0 to 2. What I'm going to do is I'm going to take 6x and combine it with 2x and make that 8x. Okay? 8x minus 2 thirds x minus 1 cubed. Okay, these two combined. Minus 2 over pi sine of pi over 2x from 0 to 2. Whew, okay, well, you know, like I said, this one is going to be very heavy with the algebra. So for every x, I'm going to throw in my 2 first. So we have 8 times 2 minus 2 thirds 2 minus 1 cubed minus 2 over pi times the sine of pi over 2 times 2. Well, that's going to be nice. So this is the whole first part. That's the upper bound. Minus, now I got to put in the lower bound, zeros. Okay? 8 times 0, that's nice, it's going to be 0. Minus 2 thirds times 0 minus 1 cubed. Okay, that won't be 0. Minus 2 over pi sine of pi over 2 times 0. That's going to be nice as well. I think we're actually going to have a lot of nice things happening here. So let's start at it. 8 times 2 is 16. 2 minus 1 is 1. 1 cubed is 1. 1 times 2 thirds is just 2 thirds. Okay. 2 times pi, well, 2 times pi over 2, these cancel. The sine of pi is 0. 0 times anything is 0. That's nice. Woo! Minus 8 times 0 is 0. 0 minus 1 is negative 1. If I cube negative 1, it will stay negative 1. Negative 1 times negative 2/3 is a positive 2/3. And again, this is 0. The sign of 0 is 0. That simplified very nicely for us. It took us a lot of work to get there, but it simplified very nicely. So now I have 16 minus 2/3. Distribute this minus another 2/3. Okay, let's write 16 as a fraction with a 3 in the bottom. That's 48 over 3 minus 2/3, and 2/3 is minus 4/3. My goodness, that is 44 over 3. That is the area between the curves. That was a lot of work for a part A. I mean, that was a lot of work for a part A. Look at that. But guess what? It's done. And guess what? It's right. I don't mind putting in the work when I get the right answer. All right, 5B. Region R, let me scroll this down here, is the base of a solid. For the solid, at each x, the cross section perpendicular to the x-axis has an area, A of x, which is 1 over x plus 3. Find the volume of the solid. Oh, piece of cake. Okay, I hope you guys know that whenever I want volume, I just integrate area. That's a big thing to know. This is the area. And we still want it because we're still using the shape from 0 to 2. Okay? So let's integrate from 0 to 2 my area, which is 1 over x plus 3 dx. If I do this right, this is just the ln, or natural log, of x plus 3, and I want that from 2 to 0. I mean, this was a piece of cake. After that first problem, they better have given us something nice. So I've got the ln of 2 plus 3 minus the ln of 0 plus 3. Pfft, we're done. What did this take us? 13 seconds? It's the ln of 5 minus the ln of 2. Oh, yeah, that's 3. When I say 2, kids, I mean 3. Man, thank you, AP, for giving us such an easy question. Oh, and they gave us another easy one. Man, problem 5A. Problem 5 was all 5A. If you could do 5A, the rest of this is cake. And I think I say this a lot. I love cake. All right, right. But do not evaluate an integral expression. Oh, I'll give you expressions all day long if you're not going to have me do the math. Come on now. Okay, so write but do not evaluate the integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. So first off, 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. This is 6 right here. If I were to rotate my shaded area around this line, okay, I will get 2 circles. This bigger circle will rotate around it, come all the way back. Okay, don't forget that is my g of x. Okay. And my smaller circle, oh my God, from here would just be this little circle here. From h of x, okay? So remember, when we integrate, we have a disk. No, we have a washer because there's a hole in the middle. There's a hole right there. So I want to take, I'm going to integrate the area of a circle, it's pi r squared. Normally we would do r squared here. But when we have two circles, it's the bigger circle radius squared minus the smaller one squared. The bigger one is going to be my g of x. However, okay, let's do this right now. Okay, I got to take 6 and I got to subtract. Let me show you here. The distance from here to here is the overall distance of 6 minus this here, minus my g of x. So technically, it's 6 minus g of x. That's my bigger radius, and I need to square that. Okay? Minus my smaller radius. Now my smaller radius, let's do some work here. Just to drive this point home, let's only focus about the smaller curve right here, okay? I've got to take the number 6. 6 is here all the way to here. That's a height of 6. I got to subtract h of x, which is here to here. That gives me this little difference, okay? And that's the same thing I did with g of x, okay, the bigger radius. So I need to start with 6 and subtract h of x squared. Now, for the love of God and everything holy, whenever you got to write something, you don't have to write, look down here, you don't have to write this out and this out. That's given as h of x and g of x. You can put h of x and g of x in there. But if you don't put the dummy variable, they can mark that as incorrect. We're missing one thing. Can anyone guess what it is? It's the bounds. Don't forget, we're going from 0 to 2 still. 0 to 2. Hoo-wee! I hope you get a problem like this that's only an A, B, and C, where one of them is going to be a little bit exhausting, but the other two are going to be layups. I'll see you for problem number 6. Bye-bye.
Don't forget to subscribe and ring that bell.